So the second thing some students asked for were some Snell's laws examples. So what I did was I printed off a couple off the internet so you can still do the ones I assigned for exam review. I do diagrams with all of these so I can straighten them out in my head. And if you're not sure what Snell's law is, Snell's law looks like this. N1 sine theta 1 equals N2 sine theta 2. It's on the first page of your exam that you all received. So light passes from diamond. So if I think about it, here is my two. There's diamond. Diamond has ND is 2.42. That's the index of refraction. That's a subscript. I like to use subscripts that refer to the material instead of 1 and 2. And we have air. N of air is 1.00. The angle of refraction. So I'm going to put in my normal, okay? Sometimes the 90 degree there just messes you up. You should know that's 90 degrees. So we have air and we have diamond. Here's our change in medium. The angle of refraction as light emerges from the diamond. So light passes from diamond into air. The angle of refraction as the light emerges from the diamond is 25 degrees. So emerging from the diamond, what is the angle of incidence? So just draw some random angle. We're looking for theta D. So theta air is equal to 25 degrees. So instead of me doing N1 sine theta 2, N2 sine theta 2, what I choose to do is do N of diamond sine theta diamond equals N of air sine theta air. And if you have some forethought, just write the one that you're looking for on the left-hand side. So we're looking for this. We're looking for the angle in diamond, so theta D. So there's two ways of doing this. You can write the things in and then rearrange it. Then you realize what you need to get. So let's put in what we have. So N of diamond we have 2.42. We don't have the theta diamond. That's what I want. N of air is 1, and sine theta air is, let's put that in, that's 25 degrees. So I'm going to rearrange this a little bit. Now don't forget that this right here, sine theta d, that is a number. This theta is trapped inside the function, the sine function. So what I'm going to do is I'm going to divide both sides by 2.42 because here they're multiplying. The opposite of multiplying is dividing. Whatever I do on one side, I have to do to the other because I need to keep this balanced. I need to keep this equation balanced. So 2.42 divided by 2.42 is 1. So I'm left with sine theta d. And on the right-hand side, 1 times anything is that. So I'm left with sine of 25 over 2.42. Now, if you want, you can go ahead and solve for that. I don't prefer that way because I don't like carrying a bunch of decimals and numbers, but I'm going to show you anyway on the calculator how to do that. So make sure your calculator is in degrees. If you can't see that, is a little d. So sine of 25, you can hit equals, and then divide by 2.42, and that is 0.17463. If you have 4 or 5 digits, it's probably enough, or you can just keep it in your calculator. That's what I do. So now, I need to get this out of the function. Well, you have to do the opposite. The opposite of sine is sine inverse. So if I take the sine inverse of this side, I need to take the sine inverse of this whole thing. Notice I'm doing the whole thing here, not just the numerator. All right, it's the whole thing. So sine inverse of sine ends up just with the theta d. All right, and now this thing is what you need to put in your calculator. So I need to actually find the sine inverse of this, which is in my calculator right now. That number's in there right now. So I'm going to take that and show you how to do that. So the inverse functions are second functions in the calculator. And so that's shift. If you can see, and I can't zoom in here, see if I can bring this up a little bit closer. The shift isn't a yellowy, goldy orange. And so are these inverse functions with the -1. So I'm going to press shift, sine, So I can see the -1. Now I want this answer to come back up, so I'm going to hit my answer button down here. That means I'm going to find shift of that and hit equals, and I get 10.057. So that means that my theta d is equal to that. I should round that to the closest degree usually. So that's going to be 10 degrees. So that means that therefore the angle of incidence is 10 degrees, approximately. All right, and does that make sense? Well, let's think about that. Diamond is really optically dense. So this is going to be 10 degrees, and it should be a larger angle when it emits into air because air is less dense and it races away from the normal. So that was number 4. Okay, this one. So I'll go ahead and do number 6. You could always pause here. You could do number 5. The answer is 1.88. So you can try that one out. So I'll go ahead and do number 6. Let's do number 6. Again, I would do a picture. When light travels from an unknown material into glycerin, gives us the index of refraction of glycerin, the critical angle is found to be 50 degrees. What is the index of refraction of the first material? Now, to be able to do this one, you need to know what the critical angle is. So let's draw a picture. So here's my change in medium. This is our unknown. And it says it travels from an unknown into glycerin. Glycerin. All right. Tells us the index of refraction of glycerin is 1.47. This one N is unknown. And let's put in our normal. Okay, so now what does the critical angle mean? The critical angle is found to be 50 degrees. All right, so that means that when, maybe I'll do this in a different color, the ray of light comes in at 50 degrees, okay? If it's the critical angle, that means that the ray of light, the angle of refraction is 90 degrees. All right, because after that, it's going to be totally internally reflected. So here's our two mediums. We actually know what the theta in the glycerin is. Theta G is 90. So, and I know that theta of my unknown, why don't I just put no subscript on that one, is 50 degrees. So I know an angle. I don't know this index refraction, but I know these two. So here's my N sine theta equals N glycerin sine theta glycerin. So this side of the equation all has to do with glycerin. This side of the equation is all of our unknowns. So this is going to be sine of 50 degrees because it's in the unknown. And this index of refraction is 1.47. And then it's sine of 90 degrees. If you know what sine of 90 is, great, put it in. If you don't know, sine of 90 is 1. So literally it doesn't even matter that it's here. Because this ends up being 1. 1 times anything is the anything. I want to solve for n, so that means I need to get rid of this. Now don't forget, this is a number. So I need to solve for n, so I'm going to divide by sine theta. Whatever I do on one side, or I have to divide by sine 50, whatever I do on one side I have to do on the other. So that divides that out and I'm left with 1. So on the left hand side it's just the n. And I have to solve for whatever is left over here. This is 1, so I just need to solve for 1.47 divided by sine of 50. So let's do that on the calculator. Here we are. So 1.47 divided by sine of 50 equals 1.9189. Now we will round that to 2 decimal places, 1.92. Therefore, the index of refraction is approximately 1.92 for the unknown material. So with that one, it's a good little question because you have to know what the critical angle means. Okay, so you guys can try number 5 for practice and any of the assigned questions from the textbook. Remember, send me an email if you don't, if you have a question, and I will try and check it tonight before I go to bed. Bye.